Hello everybody, Sorlian here and welcome back to another mathematics video. In this video, we will be continuing from where we left off with bearings. In the first video, we laid the foundation as it relates to bearings. We looked at constructing diagrams from simple bearings questions. We looked at the cardinal points and we looked at properties of angles that you will use regarding bearings. So from that video, this video we will continue with that and we'll use the knowledge gained here to solve questions as it relates to bearings. So the key thing that we should know whenever we are solving any bearings question, the key is in the diagram. You must construct the diagram first of all. Constructing the diagram will help you to understand what the question is saying and will help you to answer the question correctly and will also dictate what you will use to answer the question. And of course, whenever you're dealing with bearings, you will use either of two things. Either you will use one of the trigonometric rules, either the sine rule or the cosine rule, or you may use a property of an angle or the triangle or something to answer the question. So those are some foundational things that you must have that we looked at in the previous video. So with all of that being said, at the end of this video, you should be able to solve problems involving bearings. So of course, let's look at our first example. So the question says, a ship sails 20 km northeast, then 18 km south, and then stops. A, how far is it from its starting point when it stops? And B, on what bearing must it sail to return to its starting point? So let's separate up the page. On this part of the page, I'll draw the diagram and I'll work the question on the other side. So let's draw this diagram first of all. So the ship sails 20 km northeast. So first of all, we must have a starting point. So let's start here. So we can call this A. So the ship sails 20 km from A, northeast. So remember, the first thing you need to do whenever you are dealing with bearings from a point, you must draw in the north line because you always start measuring the bearing from the north line clockwise. So you draw in the north line and then we go 20 km northeast. So northeast would be directly in the middle between north and east. So that means it's sailed on a bearing of 45 degrees or 045 degrees. So we can go here to go 45 degrees. So 045 degrees. And then from the point here, it sailed 18 km south. So we can write in this 20 km here, 20 km. And then it sailed 18 km south. So of course, to get south, we must draw in the north line as a reference. So this north line is parallel to the one that we have before. So here's north and then it sailed 18 km south. So south would be right in the opposite direction of north. So south would be right at the bottom here. So 18 km. And then we of course complete the triangle. So let's label. So we can call this part B. We can call this point here C. So we know the bearings here, since it's south, it would be 180 degrees. And what else do we know? Do we know anything else? No, we don't know anything else. Anything else we have to find. So how far is it from its starting point? So they basically want us to find AC. So before we can find AC, we must have an angle in this triangle. If you look at A, B, and C, if you look at the point A and this angle formed here, and we look at this north line here and the south line here, we can see a little Z. So because it's a Z, let me draw it, let me isolate it. So here is the north, then we have this line here, then we have south. So we can see a Z being formed here. So because it's a Z and here is 45, that means here will also be 45 degrees. So the angle between here would be 45 degrees. So that's one way in determining which one of the rules we want to use, one of the trigonometric rules. So we have a side here, we have another side here, and then we have the angle right in between. So we know when it's like that, we have to use the cosine rule. So let's use the cosine rule. So let's label. So we know opposite B would be small b, opposite C would be small c, and opposite A would be small a. So we want to find B. So B would be the subject of the formula. So we can say A, the part A. So we can say B squared is equal to A squared plus C squared minus 2AC, all multiplied by cos B. So we work this out. So B squared will become A squared would be A is 18, so this would be 18 squared plus c squared, which is 20, so this will be 20 squared minus 2 times AC. So A is 18 multiplied by C, which is 20, multiplied by cos B, which is 45. So we can work this out. So B squared will be, so 18, when you squared 18, you will get 324, so 324. So 324 plus, when you square 20, you will get 400. Subtract 2 multiplied by 18 multiplied by 20 multiplied by cos 45 will give us 509.11. So you can say, you can round it off to the nearest whole number. So we can say 509. So next, B squared will be equal to 324 plus 400 minus 509 will give us 215. And then we are squaring the B. So to solve for B, we take over the square. So this will become B is equal to the square root of 215. Hence B is equal to, you can say 14.66. So if you want to round this off to its nearest whole number, B would be equal to 15 km. So to answer the question, we can say therefore, the ship is 15 km from its starting point when it stops. So you can put in 15 km there. So that's the answer to A. So of course you need to answer B as well. So B is asking, on what bearing must it sail to return to its starting point? So it's asking us for this bearing. So the ship stopped at C. So we need to know the bearing. So of course, if we draw up the north line, it will be right here from C. So we need to know the bearing all the way around to this point here. So if we can find this angle in between here, we can use that to get the bearing. So we see we have this angle here and we have all the sides. So that means we just have to find one angle. So that means we can use the sine rule. So the sine rule says, since we want to find for angle C, we can say C over sine C is equal to, and we know angle B and side B. So we can say B over sine B. So we put in all the things that we know and we should have just one unknown remaining. C would be 20 over sine C, which will be sine C, the thing that we want to find, is equal to B, which is 15 over sine and B, which is 45. So now we do some cross multiplication. So we'll end up with sine C multiplied by 15 is equal to 20 multiplied by sine 45. So sine C would be equal to 20 multiplied by sine 45, all divided by 15. Sine C would be equal to, so we work this out in our calculator. So 20 multiplied by sine 45 would be equal to 14.1421, and all of this will be divided by 15. So we can say 0.9428, and C would be equal to, so we take over the sine, it will become the sine inverse. So it's sine inverse of this answer, 0.9428. So C would be equal to, and we take the sine inverse of that second function, sine, which gives us sine inverse, 0.9428. We will get C is equal to 70.5 degrees. So we can round this off. We can round this off and say C is equal to 71 degrees. So if C is 71 degrees, that means here is 71 degrees. So if there's 71 degrees, that means the remaining part would give us the bearing. So we can say 360 subtract 71 degrees would give us the bearing. So 360 subtract 71 would give us 289. So that would be the answer. So the bearing would be 289. So to answer the question, I already answered it up here. Therefore, the ship must sail on a bearing of 289 degrees. And that would be the answer. it must sail on a bearing of 289 to get back to its starting point. And that is how you answer a bearings question. So it's kind of a lot of work, but the key, once again, is in the diagram. So of course, you must look at another question. So let's look at this question. Slightly different. So this one says, an aeroplane flies 400 km on a bearing of 055 degrees. It then flies on a bearing of 300 degrees until it is due north of its starting point. How far is the airplane from its starting point? So let's separate the diagram. So let me draw a line to separate. So first of all, let's draw the diagram. An airplane flies 400 km on a bearing of 055, well, 55 degrees. So we can get a starting point here. And in reference to the starting point, you must draw the north line. So you draw up the north line and then it flies 55 degrees. So 55 degrees from the starting point would be about here. And then we draw the line. So it sails from here, it sails 400 km due north. So we can put in a 400 km and the 055 degrees. And then from here, it flies 300 degrees until it reaches north. So we can say 300 degrees. Of course, you must draw in the north line to get a reference point. So north, then it goes 300 degrees. So we know here it'd be 90, 180, 270. So 300 degrees would be somewhere between here. So it sailed all the way around here to 300 degrees until it is due north. So I can extend this north line. So until it is due north would be right there. And that would be our diagram. So how far is the airplane from its starting point? So let's call A its starting point. And we can call here B. We can call this point C. So we need to find what is the value of AB. So to find AB, of course, we must have an angle. Let's see, what else can we find? We just know